Hello, and welcome to this lesson on carbon nanotubes. In today's lesson, we will first describe the structure of carbon nanotubes before moving on to look at their properties. We will then explain the significance of applications of carbon nanotubes in nanotechnology, electronics, and material science. Previously, we dived into the structures of diamond, graphite, graphene, and fullerenes. Building on this foundation, today's lesson will advance our chemical understanding by exploring carbon nanotubes. Through understanding their unique structure and remarkable properties, we will see how they bridge knowledge from familiar carbon structures to cutting-edge applications in modern technology. This will deepen our insights into how molecular-level designs can lead to significant advancements in various scientific fields. Let's dive into the fascinating world of carbon nanotubes by starting with their structure. Carbon nanotubes are a class of fullerenes. They are cylindrical structures composed of carbon atoms. Picture a sheet of graphene, a single layer of carbon atoms arranged in hexagons. Now imagine rolling that sheet into a cylinder. That cylinder is a carbon nanotube. One remarkable feature of carbon nanotubes is their aspect ratio, which is the ratio of length to diameter. Carbon nanotubes can be incredibly long in comparison to their diameter, often reaching lengths thousands or even millions of times their diameter. This high aspect ratio is a key factor in their unique properties. The unique structure of carbon nanotubes gives them several exceptional properties. First is their high tensile strength. Carbon nanotubes are incredibly strong when pulled, making them highly resistant to breaking under tension. Despite their strength, carbon nanotubes are also highly flexible. They can bend without breaking, which is a rare combination of properties. Next is their capability as electrical conductors. Carbon nanotubes are excellent conductors of electricity. Their electrical conductivity can surpass that of metals like copper, making them highly valuable in electrical and electronic applications. They also possess remarkable thermal conductivity. They can efficiently transfer heat even better than diamond. Finally, they are extraordinarily lightweight. This, combined with their strength, makes them ideal for strengthening materials without adding much weight. Next, let's explore why carbon nanotubes are so significant in the fields of nanotechnology, electronics, and material science. In nanotechnology, which is a field concerning very small particles, specifically on the nanoscale, which we will look at in the coming lessons, the minute size and exceptional properties of carbon nanotubes enable them to be used in creating nanoscale devices and materials. Their high strength and thermal conductivity make them perfect candidates for building robust, efficient components at the nanoscale. In the realm of electronics, carbon nanotubes are showstoppers. Their superior electrical conductivity allows for the development of highly conductive wires and components that can downsize current electronic devices while enhancing their performance. Imagine tiny, super efficient circuits and components. Carbon nanotubes make this possible. In material science, carbon nanotubes are revolutionizing the way we create and enhance materials. They are used as reinforcements in composite materials, significantly improving the mechanical and electrical properties of these composites. Adding carbon nanotubes to a material makes it stronger and more conductive without adding much weight. This is routinely done in creating advanced materials. In today's lesson, we delved into the fascinating world of carbon nanotubes by examining their structure and properties and exploring their significance in various fields. We learned that carbon nanotubes are cylindrical structures made of carbon atoms arranged in a hexagonal lattice, similar to graphene. Their high aspect ratio, which is the ratio of their length to their diameter, contributes to their unique characteristics. We understood that the exceptional properties of carbon nanotubes include high tensile strength, flexibility, excellent electrical and thermal conductivity, and lightweight nature. These properties make carbon nanotubes incredibly resilient and efficient for various applications, including in nanotechnology, creating small and efficient components, electronics, as they are highly conductive, and in material science, reinforcing materials without adding much weight. Through this lesson, we have seen how the unique structure and properties of carbon nanotubes make them indispensable in advancing modern technology and material science.